Welcome to this Ignite webcast. My name is Josh Topal, and I work on the Office 365 team. And Ignite events are a series of technical workshops for IT pros and Microsoft partners. So this Ignite webcast series will address different technical subjects and scenarios that are really beneficial to anyone who wants to increase their knowledge of the Office 365 suite. So today we're really excited to have Abram Jackson lead us. Abram is a web program manager for the high availability team. And in today's webcast, Abram will be diving into managed availability. So again, the session really provides a great opportunity to hear directly from someone at Microsoft who's worked so closely on Office 365. And today's webcast will be about an hour, and we're going to leave a few minutes at the end to field any questions from anyone on the call. So you could type your questions into the link chat box, but I ask that you wait until the end when we have the Q&A portion of the call. We are recording today's session, so you can see the video recording, and we'll have the PowerPoint presentation that you see here up on the original blog post and up on the Ignite site, which I'm going to go ahead and paste into the chat window there. One last thing that I need to mention is that since we are recording today's session, please understand that you may be captured in the recording. So if you do not wish to be recorded, please don't type into the IM window. Or if you want to be extra safe, please feel free to leave the meeting and then you can watch the video at a later time. So that's it for me. Abram, whenever you're ready, we can get started.
Thank you, Josh. Hey guys, hopefully you've been reading up on managed availability, some of my blog posts on EHLO, or possibly a Tech Ready, Tech Ed, or Mech, or various sessions like that. So I'm not going to spend a lot of time on PowerPoint today. I'm going to spend most of the time in a demo, and I'll try to be, very descriptive and go slow through the demo, but I'm going to go fast through the PowerPoint because hopefully you've seen similar information before. So the big point of managed availability is that we found when running the service that stuff breaks, right? When you scale to thousands of machines and hundreds of millions of users, things are not going to work correctly. And so we built this unified framework for protocols and teams and components to self-recover, basically. And we built this for the service and integrated it with on-prem and really built it for both. So in a common scenario, a user uses OA to send mail. It goes through the OA protocol on that mailbox server, and it goes to that database on that server. Remember that in the Exchange 2013 architecture, all processing is handled by the mailbox server where the active database is. Anyway, so if OA fails, users can't access their mail on database 1 through OA. So what OA does is recovers itself by restarting, or maybe resetting an IIS app pool, or doing something else. Now it's healthy, and mail can still go through, still go to that server. But if OA fails again, and it doesn't recover through resetting the IIS app pool or doing something else, it can fail over that server's database, so that users whose mail is on that database is no longer connecting to that server, and now they're connecting to a server with a healthy OA. And then when OA is verified as healthy, maybe an admin took an action or some other recovery happened, the databases could fail back to that server. So really that's the basic idea. Now that all of these protocols and all of these processing has to happen on the server that's handling the active database, we need a way to determine that everything is healthy on that server. So managed availability, I like to think of it as three main parts. There's the probes, there's the monitors, and there's the responders. Here you can see that probes are technically three different categories. There's probes, checks, and notification items. There's monitors, and then there's recovery actions. So across Exchange, tens of people built monitors for their components because they know what constitutes their component is healthy. And they also built those probes. Anyway, so probes integrate into monitors. Monitors take recovery actions, basically. All of this is local on that server, and then it's uploaded. It can be uploaded into SCOM and viewed there. The last box here that I didn't mention is escalate. If managed availability can't fix a problem, it has the mechanism to escalate, and you'll see errors in SCOM. All right, so here's the pipeline. You can see probes are sampling, monitors are detection, and responders are recovery. All these names kind of mean about the same thing. So the probe is defined. All of the probes run every few seconds or every few minutes. Monitors are watching those probes, and then when enough of the probes fail, as the monitor defines, it runs responders. So monitors are generally green, and then the monitor is healthy. If enough probes fail over the monitoring interval, that the monitor should turn red. It will turn red and it will start executing recovery actions. And so these are sequenced, and as soon as a recovery action restores service well enough that probes start passing, then the monitor goes back to green and stops taking any more recovery actions. So as soon as the monitor turns red, you could call it time 1, the actual code will call it maybe like unhealthy 1 or something like that. And maybe at time 1, it will take an action like resetting the IIS app pool or restarting a service, something that can complete quickly. If that doesn't succeed, in a few seconds or in a few minutes, depending on what we've seen works best for that kind of action, if the monitor is still red at 10 seconds or 30 seconds or 2 minutes, it may do the next action, like fail over all databases from that server. And if probes do not start passing after that point, then it may escalate. So this is a very generic model that applies to basically anything on this mailbox server, right? Any exchange thing on this mailbox server, because it's generic enough, and probes can really write, can be any code that the author decided. We can find out if anything is healthy. I could briefly mention that some are checks, which are based on perf counters instead of probes. And then notification items instead of recurring probes are code running in other parts of the service that just directly writes basically a failed probe. Anyway, enough talk. I don't mean Q&A yet, but time for demos. So bear with me while I switch to a demo. Okay. Here we are. So, hope everyone can see me. So, what I'm going to start off with is disabling the Microsoft Exchange REPL service so that you can see managed availability in action. Okay. So the Exchange Replication Service is under the Data Protection Health set, which you'll see here in a little bit. And we'll wait for it to stop. All right, so it stopped. And so you'll quickly see that it's stopped because it will show a service down on the server. I'm using 4465. Okay, so the service is stopped, and so basically one of these managed availability components is not healthy. All right, so let's look for the probes that are tracking this scenario. So I'm going to start off with get win event. This is basically just the command line version of the event viewer. We're looking at the application log, at Microsoft Exchange Active Monitoring, the probe definition. Okay, and then we're just going to take the properties and convert them into XML, which PowerPoint likes nicely. For future commands, I'll copy them in, but I just want to explain to you what I'm doing as I go through it. Okay. Okay, so this would get me all of the probe definitions that are defined on this server, including the ones that are tracking whether the MS Exchange replication service is running. So one way to go about finding the specific one is choose the name, like MS Exchange REPL. And you can't necessarily count on this, but I'll show you another method in a little. But this is one way that will often work for most of the services. Okay, so here are 4 probes that the MS Exchange replication service, or that the monitor that we're monitoring. You can see that one is service health MS Exchange REPL crash probe, which is basically just if it's crashing too often. Then there's a few subcomponents of MS Exchange REPL. Okay, so we could also do this with so first you could do this for sure in the event viewer and just use find, but I'll show you really the way that we wanted this to work. So get monitoring item identity. Data protection is the health set that I know that this is under. So this will get me all of the probes, monitors, and responders that are defined on this server. The data protection one, there's a few more than normal. You'll see that there's a target resource for every database. So database health, database copy, failed and suspended escalate is defined for each of these databases, right? So there'll be more than normal under this health set. So here are the 3 that we were looking at before. You can see that the target resource is MS Exchange REPL. All right. So this is the command that you normally use to find the probes, monitors, and responders for this. Okay. One other way that I wanted to look at this here. This is the former command. So this is the probe definition, and you'd see this in the details of Event Viewer if you looked up this in the probe definitions channel. So I was going to go through some of these properties. Remember that all of these are overridable using add global monitoring override. So the type name is just the code name of this code. That's pretty basic. This is the name of the probe. So you can see that this is one of the service health MS Exchange REPL endpoint probes. We've got 3 of them: server locator, TCP, and RCP, RPC rather. Service name is the health set that this probe belongs to. Deployment ID, execution location aren't really used. Created time is when this probe was defined, and it's defined when the HM worker restarts or every 15 minutes if it sees that there's changes. It's currently enabled. 0 would be disabled for this probe. This is the resource that it is probing against to make sure that it is up. This recurrence interval seconds is how often this probe runs. So if the MS Exchange replication service is stopped or not working for within 45 seconds, this probe will detect it. Timeout seconds is how long this probe will wait for a response. If it goes past that, we say that it is not running. Start time and update time are not really used on definitions, but I'll show you how that looks in a result in a little bit. Max retry attempts is if it fails in certain ways, we'll retry it immediately, in case it's something very transient. Extension attributes is used by some monitoring item types. It's not used by this one. It's just when that sort of probe or monitor needs additional information. These other ones are also used by some probes in various ways, however they're necessary. Okay, So that's what the probe looks like. So let's see if there's been any probe failures. Here, I'll copy this one in so you don't have to watch me type it all in. But I'll also explain it. So this is looking in the probe result channel. Every probe execution is logged here in the probe result. This filter XPath is just a way for me to use getWinEvent to look for a probe that has the result name of Service Health MS Exchange REPL Endpoint Probe RPC and the target resource. This result type is another property you can see in the details. 4 means that the test failed. 3 means that the test succeeded. Okay, so let's see what we found. Well, first let's see how many there are. 1,723. So I actually increased how often this one is running earlier. Okay, so let's look at the first one. Okay, so this is a probe result. You can see that there's a lot of information, right? And since, there's many probes running every second, you get a lot of information on how your service is running. So let's look at some of the interesting properties here for a probe result. You can see that it's still under the health set data protection. The result name is what we queried against. So this is the probe name that you saw in the in get monitoring item identity, and this is the target resource you saw in the get monitoring item identity. So basically, probe result name will be the probe name / and the target resource. Okay, work item ID is unique ID for this type of probe, so you can query on that instead if you wanted. This is the server that is running on, of course. And here's the error message, right? So you can see here the MS Exchange replication service may not be running on the server, which is exactly right because you watched me shut it off. The exception you may also be able to use to get more detailed information or contact support, of course. These state attributes are used by various probes in various ways, however they want to. So here you can see what task is being executed, a more friendly error message in this particular case. There's more state attributes that can be used. The result type is what I told you we were looking at. That means that the test has failed. This is when it executed, or when it started executing. This is when it finished. That's probably the minimum granularity we have. Poison count. Let me explain the concept of poisoned probes. If running a probe causes the HM worker process to die, to a seg fault or something, so then the HM worker needs to restart, but then it will mark this probe as poisoned and stop running it. And so we make sure that this isn't happening for on-prem builds, but when we're developing things, we may see stuff like that. And then we'd want to fix it, fix whatever the problem is. Extension XML is some XML properties that the author could have defined. And the rest of these are all internal if they're used. Okay, so that's why the probe is failing. And of course, it's obvious why the probe is failing because I shut off the service. But let's look at what monitors are tracking this, the replication service. So I'm going to use this command, which is basically just getting the entire results of the active monitoring monitor definition event log channel. And of course, you can get this in Event Viewer as well, and I'll show you that a little bit later. Let's see how many there are. There's 1,028 different things that are being monitored on the server. Of course, some of those may have multiple probes. Okay, so let's find the monitor that is being used to watch these probes. Sample mask is a monitor property that matches the probe names. We know all of the probes match Service Health, MS Exchange, REPL, Endpoint Probe. Okay, sorry, got lost there. Okay, REPL probe. And okay, let's see. What do we want to look at? Let's just look at. Okay, this should only return 1, and looks like I spelled endpoint incorrectly. Okay, here we are. So this is the monitor definition that is watching probes like Service Health MS Exchange REPL endpoint probe. We were looking at the sample mask. So let's look at the properties of this monitor. So the ID is unique to this monitor. I normally recommend using the name instead. You can see that its type is an overall X failures monitor. And so you can read one of my blog posts on EHLO for the different common kinds of monitor. This one, overall X failures, will watch over the monitoring interval for X number of failures, basically. There can be some successes during that time, but as long as X of them are failed. And since we know how often the probes are running, we can say, exactly 8 out of 10 or 14 out of 15 or whatever we're doing. Service name, once again, is the health set. This is when the monitor was defined, which again is when the HM worker has started or noticed a change. Remember, all of these properties can be overridden, right? And that turns out to be a lot that you can do. Enabled is a common one you may want to override to shut off a single monitor that you know is having a problem in your environment and is designed that way. Enabled 0 would be false. This is the server name. This is how often the monitor runs. Now, in this demo environment, monitors don't run quite this fast, but I wanted to have the monitor actually be able to turn red in a demoable amount of time instead of 10 minutes. Recurrence interval seconds is how often that the monitor is running. Timeout seconds is the same as the probe. If for some reason the monitor can't execute, and this is pretty rare, but it will time out in 30 seconds. Max retry attempts is less useful for monitors because they're pretty standard. Sample mask is what we looked at. Monitoring interval. So we look at 180 seconds. We look at the probes in the last 3 minutes. And as long as X of them have failed, this monitor will turn red. And that will have T0 like I showed you in the PowerPoint. Okay, monitoring threshold, instead, I shouldn't say X, I should say 4. So if there are 4 probe failures in 180 seconds, this monitor will turn red. And remember, there's other kinds of monitors, and I go through that in my blog post, where some use the monitoring threshold and some use the secondary monitoring threshold for various ways. Okay, service priority is to sort of group some of our monitors together to determine their relative priority, especially for database failovers. If a low priority component is unhealthy, but a high priority component is healthy, it may still be a valid place to mount a database. Is HA impacting? This is an important one because this determines where a database failover will go. So if a monitor that is HA impacting or high availability impacting is red, we'll try not to mount there. Basically what that means. If it's not HA impacting, then we can still mount there. Insufficient sample interval seconds. This is basically used internally, but if for some reason the probes can't execute, for whatever reason, maybe a code bug or maybe maxed out CPU on the server or something like that, the monitor won't turn red if there weren't enough samples. Okay, component name, you can see it's data protection. This is our priority. It's high on this one. Okay, state transitions XML. This is an interesting one and one that you may want to set an override on. And I went through this a little bit on a blog post too. But you can see that it's a grouping of state transitions where the monitor will transition into those different, basically different states. And then as soon as the monitor is in that state, it executes the responder that is defined to run on that same state. Okay, so when this monitor is degraded, so I should say when the monitor is red for 30 seconds, it will be in the state degraded. When the monitor is read for 60 seconds, because the recovery action at 30 seconds didn't work, it will move to degraded 1. And so on, right, until it goes through all of the state transitions. This last one is usually an escalate. Allow correlation to monitor is used internally to take dependencies on other monitors. All right, so that's a monitor definition. If you have questions on that, you can write them down, and I'll try to get to them at the end. All right, so let's look at the specific monitor result. So this is a monitor definition. Remember, monitors execute, this one executes every 25 seconds, and so you'll see a monitor result every 25 seconds. So I'm just going to copy this in so you don't have to watch me type it. So again, I'm just using Windows Events to get the monitor result channel. I'm looking for the monitor results that have the monitor name followed by its target resource. You can see that up here, the REPL endpoint monitor, and here's the target resource. Is alert equals 1 means that it was basically a red monitor, so that this result either turned the monitor red or confirms that the monitor is still red. And here I'm just converting it into XML again. These result channels tend to get very full very quickly, right? Because multiple monitors, right? There's 1,000 of them running every minute or 5 minutes, and so they tend to be pretty common. Okay, so let's see how many failed monitors we see. All right, already 1,842, probably because I was trying this out last night. So let's look at the first monitor result. I can show you some of these properties, if any of them are useful. Okay, so here you can see the result name that we queried on. There's the machine that it's running on. If for some reason running the monitor hits some sort of error or exception, the state attributes are used by some. Result type of 3 is basically just that the monitor was able to get the results that it wanted. In this case, they were failed results, which is why we see that isAlert is equal to 1. Here's the start time. The total sample count is the number of probes that have executed in this monitor results execution interval. Remember, I showed you that was 180 seconds. So this probe, the probes that it's watching have executed 12 times in the last 180 seconds. All 12 of them are failed. This new value is not used by this type of monitor. Let's see. This is the probe ID, so you could also search for that in the probe results channel or the probe result ID. Okay, the health state transition ID. I'd have to look up this enum, unfortunately, but I know that 4 means that this monitor is red. There's some other values, green basically, and then there's also poisoned, for instance, is also in there. This is when the monitor turned red, and so this monitor, you can see that it was not the first one. You can see that this was at 1615, but this one was actually at 1627. So it turned red at the monitor result before this, and so that's when the first monitor result ended up being red. Okay, first insufficient samples observed time, that's null because we don't have insufficient samples. The state attributes are used by some of the monitors in various ways, not used by this one, and so each monitor will use that a little bit differently, so I can't give a good description of what each one will do. Is HA impacting? You saw that from before. And the component name is the same as before as well. Okay, so we see that this monitor is turned red from the probes that have determined that the MS Exchange replication service is not responding, clearly because it stopped. All right, so maybe you thought that was, way too complicated to go through. So 2 answers to that. You can use the event viewer, or you can use our our commandlets. Okay, so this is in the data protection health set. And here you go. Okay, so get health report shows that this health set on this server is unhealthy. So you can go into the details in two different ways. I'll show both. Here's one method of getting the details, but the bona fide method is get server health. And to clear out some of the noise, I'll just look at the ones that are not healthy. I got an extra quote in here. There, let's auto-size that. Okay, so you can see several of the monitors on this server are not healthy. Now, the server 1 copy monitor is not healthy because I've got a database on the server that's not replicated, and so that one can be, I know it can be ignored. The one that we've been looking at is the service health MS Exchange REPL endpoint monitor. Also, stopping the REPL service will prevent Active Manager from working as well, of course. So you can see that this monitor is unhealthy. So that's really the basic way to find out what monitor is unhealthy. Here, let's grab the one that is and see what details we've got here. Oops. Okay, so you can see that this is basically the interesting information that I showed you out of that entire monitor result. So you've got the name, you've got what server it's executing against, you've got which health set it's in, you've got which health set grouping it's in, which is a property that you can see in SCOM. You can see that it's unhealthy. You can see, in a nicer format when it became unhealthy. You can see that this monitor is HA impacted. You can see how often the monitor is running. You can see when this monitor was defined, which remember is when the HM worker, Health Manager worker, has processed a change or has restarted. This transition time is when the monitor specifically turned red. This is the last time that the monitor determined that enough probes had failed. This is showing that the monitor is working correctly. You can see any error or exception if necessary, is notified if it's going to move to the escalation state, and you can use these in Win Event Viewer to get the details. Okay, so the method you're going to be using a lot more often than looking through specific monitor results. And so hopefully you know what most of these mean now. If you have any questions on these, go ahead and type them in the link in the Q&A. Okay, so let's move on to responders. I'm going to run a command to get all of the defined responders that are on the server. Remember, I also did this with probes and monitors earlier. So you can see that responders are defined again in the event log, in the Microsoft Exchange Active Monitoring responder definition channel. And then I'm nicely converting it into XML. The server currently has nearly 1,400 defined responders. And we're not interested in all 1,400, clearly. So let's just find the one that's for this monitor. So for responders, to tie them into monitors, they use alert mask. And so you can see that the alert mask for these 5 responders are tied into this monitor, the monitor that we've been looking at, the Service Health MS Exchange REPL endpoint monitor. And so I looked at, so here you can see all of the responders that are tied into this monitor. and based on what state transition they will run. And so it's an int here, and it's an enum, and the monitor result. So I'll show you kind of a cheat sheet, and this is on the AHLO blog as well, for when this monitor, or what actual health states this responder is tied into. So you can see that the REPL endpoint restart is defined when the monitor has the state transition of degraded, which remember was at 30 seconds based on the state transition XML property of the monitor definition. Then it moves and restarts the second time when it moves to degraded 1, and then moves to endpoint failover when it gets to degraded 2, and then it does a force reboot when the monitor state transition becomes unhealthy, and then finally will escalate. Okay. All right, so let's look at one of these specifically. I'll just select the first one. Okay, so this is a responder definition. You can see that the alert mask is what we were looking for. It's the monitor and the monitor's target resource. So the same way that monitors and probes work together, it's the same way here. Here's the responder's name. Of course, that's unique. This is when the responder was defined. Remember, we're looking at responder definitions. Once again, all of these properties can be overridden with add server monitoring override or add global monitoring override to change really anything here. Anything that makes sense, like created time. I think you can change it, but it's not going to do anything good. Enabled, you can shut this specific responder off. Remember that this wouldn't shut off all escalate responders. It would only shut off the escalate responder that's tied to the MS Exchange REPL endpoint monitor in this case. This is the resource that this responder is running against. This recurrence interval seconds is it is used on responders, and you'll see that responders run every 300 seconds, but they will also run when the monitor changes state. And so this recurrence interval seconds on responders isn't as important. They'll still be running that often, but it will also running immediately after your monitor changes state. These are used more by responder results. This is how many times this responder will try to escalate if it hits some sort of failure in the meantime. You can see that the extension attributes actually is used here for this responder. I don't remember what this extension attribute for this specific responder means, but different responders will use this in different ways. Alert mask I already talked about. This wait interval seconds and minimum seconds between escalates. This is the first level of throttling that we have on our managed availability responders. It's generally the weakest, but it's most important so that the responder just doesn't try to escalate, 30 times in a minute. We've got other throttling levels that we'll apply later, and we'll get into some of that. So here is the alert that you're going to get in SCOM, or if you have some other system set up. This is the best information that we have to give you for why something is broken. So you can see that the replication service endpoints are not responding on this server, and you can see that it's in the data protection health set. Here's an error message, or the escalation message. Every escalate responder will have different things here. Of course, the probe.error is the actual error property on the probe result for the last one. And we looked at that earlier where it gave us a pretty good indication that the replication service may not be running. Let's see if anything else is interesting. The alert type ID is also the monitor name. And these other ones are pretty much used internally. Okay, so that's a responder definition. So let's look at the responder results, which responders have actually run based on this monitor being failed. Okay. So I'm running this one in the responder result event log channel, where the result name is the service health MS Exchange REPL endpoint restart. Remember which is that this is this name. In this case, I'm looking at the endpoint escalate. Here I'll be looking at whether we've restarted the MS Exchange replication service. This is recovery attempted equals 1, means that this responder actually did try to restart the service. Remember, this is before most of the throttling happens. Okay, there we are. Let's see how many we have. Okay, just 8. That's a reasonable number considering it's actually trying to restart the replication service. Remember, we have throttling, so it didn't actually do it 8 times. And some of these are probably from yesterday when I tried it. Okay, so this is a responder result. You'll recognize this will be old hand to you now. Service name, of course, is the health set. This is the responder name. This is the machine that I ran on. Here is the error. Okay, so since this is the replication endpoint restart responder, it's tried to restart the MS Exchange replication service. In this case, because I've also disabled the service, it can't actually start. It can't actually start it. Okay, so service cannot be started either because it's disabled or because it has no enabled devices associated with it. Of course, it is disabled. That's exactly what has happened. You can look through that exception if it's meaningful to you. The retry count is how many times it had to retry. In this case, of course, it didn't. The result type of 4 means that it was not successful. This is when it ran. Poisoned I talked about earlier. In this case, the specific one was not throttled. And so it actually did try to restart the service. Okay. Is recovery attempted? Remember, that's the property that we actually looked at. This is the responder that actually tried to execute. All right. So, planning on going through a similar demo with an OA app pool being stopped, and I was going to show how to use Event Viewer for that. So maybe I'll just do the very first part of that. Right, so I've got the event viewer. This is the monitor definition channel. So I can find the OS self-test monitor. Here it is. So these are the same properties that we looked at for the monitor definition. Here's the health set that it's in. Here's whether it's enabled. This is when it was defined. Okay, so we already looked through all of these things, and so I'm just showing you that you can also use Event Viewer for this if that's what you feel more comfortable doing. All right, but I'll skip the rest of that demo because otherwise, other than that, it's the same thing. One other very quick thing I wanted to show you is get server component state. Okay, so this is basically what we've implemented for you to be able to stop the server from either servicing users or proxying traffic or responding to the load balancer. So let me shut down. I'll just do OA proxy. Well, first, let me show you that the health check page or the smoke test page for OA on the server is doing just fine, 200 OK. Oops. Let me disable it, and oops, for maintenance. Just saw a really good blog post on EHLO about how set server component state works. And usually you'll only have to use get server component state and set server component state. But that blog post has lots of details to go really in depth with it. Okay, so here you can see that now the health check page is failing for OA. And so if you have a load balancer that can check something like this, now it knows not to route OA users through this client access server. All right, that's all the demo well, it's not all the demo I have planned, but seeing that we're down to 14 minutes left of the meeting, I think I might switch to questions. And if you have questions about specific parts of the demo or whatever. Okay, I see one question. Could you show how to override the default entry? I can. Okay, so since this is a demo environment, I've actually set up a bunch of these already. So here are the monitoring overrides that I've already set up on this server. You can see that one, here's one that I talked about that I overrode. So for this monitor, the service health MS Exchange REPL endpoint monitor, which we were looking at the definition of earlier, I set the property name, recurrence interval seconds, to 25. I believe it was 60. Let's set it back. So add global monitoring override, identity. The identity for global monitoring override takes the health set name, a backslash, and then the monitor or the probe or the responder name. And remember, those are all in the name property of the definition, or get monitoring item identity that I also showed you gives you this information. Okay, so let's see. We want to set the property name of recurrence interval seconds. Property value back to 60. Okay, there's a couple other parameters that are necessary. The item type is a monitor. You can see that it's also already right here. And either the duration or apply version. For on-prem, it makes a lot more sense to use apply version, and then it will last until you apply the next cumulative update. But I'm going to use the duration here. Okay. The error message is showing that I've already set this property name, and so that's a good point. Let's go ahead and set a different one. As the error message says, you can also remove it. Let's just, here's an OS self-test probe. I'll set this one's monitoring recurrence interval to a different amount of time. Okay. Oop. This isn't one I already set. Is it? Oh, I proxy test? Okay. Looks like I didn't. All right, there it goes. So now if I run get global monitoring override, see this one probably down or up here on the top. Okay, so I just set this to 60 for 60 days. So here's the details. Basically, these are just all the parameters that I just put in. Here's 60 days from now. Here's who said it. That can be useful. Okay, so that's pretty straightforward, I think. Now, in order for this to take effect, you'll have to wait 15 minutes, and that's just fine. Or if you want it to happen now, you can restart the HM worker service, on all the servers globally, or whichever one is appropriate for you to do. So waiting 15 minutes is probably more appropriate. Is there a way to easily find or export manual overrides, then re-import them at once after a CU is applied? Okay. So Brian is asking if it can be exported. Well, so of course, of course you can do export CSV, right? And then you can PowerShell script it to put it back in. And I haven't written a script like that exactly. If you open something like this in Excel, you pull out the properties that you can't actually set. and then you can just import it back in, scripting it to run add global monitoring override again. The other method you could use is server monitoring overrides, which are stored in the registry, and then just export that registry information. I'm not a total expert on setting that in the registry, but okay. Yes, as Belchandra has now said, export the reg entry. Remember that these are AD properties, add global monitoring override. So, so that's actually a better answer here, right? So add global monitoring override is set on the forest object in Active Directory, or under the forest object. And so the problem will be that the apply version will no longer be correct. Right, so you don't actually have to export it to CSV. You sure can. Okay, so it looks like we did not implement set global monitoring override. But at that point, then you can just get global monitoring override, pipe it in and specify each of the parameters as the new global monitoring override. And that would be pretty easy to script in PowerShell, at least in my opinion. But it'd be nice if we had set there, huh? Okay. Josh, did you get any private messages? Okay. Looks like we're wrapping up. If there's no other questions, give it back to Josh to give you some follow-up and talk about future Ignite sessions. If you want to contact me directly, you can use my Twitter handle, Abram Jackson. On Twitter, or you can also post in the high availability sub-forum on MSDN. For Exchange Server 2013 is another place that I regularly look at. Balchandra asks if we're getting a MA management in GUI. Well, so there's, we have SCOM, right, which is a health viewing ability. You're quite right that that's not what I just showed you. I'm not as familiar with SCOM. I might do a future demo on it, and so that you can see what monitors are unhealthy. But so this stuff that I showed you is actually, a fairly rare scenario for deep dives, right? So that I showed you the escalation subject and the escalation body or escalation message on that responder result. That's usually what you'll be using. Actually, let me go ahead and show that real quick. So the managed availability monitoring channel is here. So you can look at this information. You can export these events. There's not that many of them unless you're having real problems, as I am in this poorly set up demo environment. But SCOM will also give you this information, or you can set up some other tool to either email it to you or whatever else. So you can see that which health set is bad. You can see, remember I showed you the subject and the message. Right, and this is the best information we generally have to give you for the best information we have to give you to investigate. In some cases, you may want to get deep into the probe execution details, but most times this is the information that you'll want to use. In the service, this is what we use most of the time, these messages that we get from this monitoring channel on these servers. And then we go and investigate it using all of the means that we have, and often that's PowerShell, even get mailbox database copy status, but of course you can also use the admin center for stuff like that. One other thing that's useful to see is the recovery action results. I showed you actually this exact this responder result where it tried to, well, actually this is the Health Manager Active Restart service, so not exactly this one, but I showed you where it can't start the MS Exchange replication service. And so this recovery action results channel is also very useful to see what's happening here. The recovery action logs will give you when things are throttled and why they're throttled. Let's see if I can... I don't see any right now. Oh, here's some. So this server failover is something that we try not to do, all of the time. So you can see here that now is maximum in day check passed. And only one is allowed per day for this resource name. So only one server failover is allowed for EXHV-4465 a day. And you can see that that check has failed because since 9:13 a.m. yesterday, it has already done a server failover. Okay. My screen wasn't visible for that whole thing. I'm sorry, guys. Well, so I was just looking at the event viewer in the Microsoft Exchange Managed Availability Monitoring channel and Responder Results channel. The monitoring channel is basically the same information you'd see in SCOM or some other event collector.
Okay, can you hear me, Abram?
Yep.
Oh, okay, sorry, something was wrong with my mic. Yeah, sorry, the screen wasn't visible. It was still showing the
Okay,
surveys.
I'll show it here in a second.
Okay.
Okay.
Awesome. Yeah, thanks for your patience, everyone. Sorry.
Yep. Okay. So I was looking at the monitoring channel where you see that this health set is not healthy for this monitor's reason, and here is the subject and the message, which is the best information we can give for it. So you'll see this in SCOM or some other event collector, but this monitoring channel is one that you'll spend a lot more time in than all of these monitor results and probe results. And the other thing is recovery action results. Here's where a responder actually gets through and tries to gets through all the throttling and tries to restart a service or do something else. See, it's trying to restart the replication service, and in this case, it could not start it because I have it disabled. Recovery action logs, you can see, is more detailed information before, including all the throttling information. So here's the server failover that the REPL endpoint tried to do a failover earlier. It was unable to because this server has already failed over. And you can see that it's configured to only allow one per day, and that check has passed, has failed. And so it's not allowed to continue on through.
Okay, great. Any final questions here before we sign off? And I have just one more quick survey question if you have time to answer that. But yeah, let's see, let's give it one more minute. But while people are maybe thinking about a question, yeah, thanks Abram for the fantastic session, and we'll have again the video recording and the PowerPoint on the blog post and on the Ignite site. And then, yeah, our next session is going to be on Exchange virtualization, which is going to be a week from today, same time, same place. But yeah, thanks again, Abram.